Welcome, Algebra Scholars. I am Mr. Fuller, and this is a lesson from Chapter 1, Sections 5 and 6, adding and subtracting and multiplying and dividing real numbers. Let's get started with Chapter 1, Section 5. In this lesson, you're going to practice adding and subtracting signed integers, positive and negative integers. Now, I know that most of us have studied this before, but we want to do something a little different in this lesson. We want to think of positive numbers as hot cubes and negative numbers as cold cubes. And then addition will mean putting in, as if you're putting them into a bowl or a glass, and subtraction would mean taking out either hot or cold cubes, depending on whether you have a positive or a negative number. So let's look at example 1. The problem says 9 plus negative 2 equals what? So this question shows 9 hot cubes, that's the original positive 9, and 2 cold cubes, negative 2. So we have 9 hot cubes already in the bowl, and we're adding 2 cold cubes. What's going to happen is hot and cold cancel each other out, so the 2 cold cubes will cancel out the effect of 2 of the hot cubes, and we would have essentially 7 hot cubes left, and that would give us an answer of positive 7. In example 2, the problem says negative 5 minus negative 3, and this is representing that we have 5 cold cubes already in the bowl, and we're going to take out 3 cold cubes. So if there are 5 cold cubes in the bowl and we take 3 of them out, there will be 2 cold cubes left, and the answer will be negative 2, or 2 cold cubes left. So let's try this logic a little bit. Just work with me here. I know you've probably learned this differently before, but let's see if we can figure out these first few examples together. Problem number 1 says negative 5 plus negative 11. So if we're thinking hot and cold cubes, we have 5 cold cubes already in the bowl, and we're going to add 11 more cold cubes. So all of these cubes are cold. So really we just add them together and say that we have 16 cubes, and they're all cold. So our answer will be negative 16. In problem number 2, we have 14 cold cubes, and we're going to add in 13 hot cubes. There's no negative there, so those cubes must be hot. So the 13 hot cubes will cancel out 13 of the negative, or the cold cubes, and we will end up with only 1 cold cube left, or an answer of negative 1. In problem 3, we have cold cubes already in the bowl, and we're adding 9 cold cubes already in the bowl, and we're adding 15 hot ones. So now we're adding more hot than there is cold. So 9 of the hot ones will be canceled out by the 9 cold ones, and there will be 6 hot ones left, or an answer of positive 6. All right, in a few minutes I'm going to have you pause the video and practice the rest of these. I feel confident that you can do these. Keep in mind, no calculators allowed on this page. The no calculator symbol is at the top of the page there to help you remember not to use a calculator on these, so do your best to figure these out without having to use a calculator, and then you'll be able to come back or actually just look at the bottom and check your answers with the scrambled answers at the bottom of the page. But don't do those yet. Before you get to those, let's turn to the next page and let's practice some subtraction problems. 1 through 15 is all addition problems. Let's think about subtraction problems. So now looking at question 16, the question says 7 minus 13. So we have only 7 hot cubes, and we have to take away 13 hot cubes. How can we do that? Well, since taking out hot cubes makes it get colder, we can think of taking out hot cubes as the same as adding in cold cubes. That also makes it get colder. So let's take our 7 hot cubes and let's add in 13 cold cubes. In other words, let's just rewrite 7 minus 13 as 7 plus negative 13. Now the problem makes a little bit more sense. We've got 7 hot cubes and we're adding in 13 cold cubes, so the 7 hot ones will cancel out 7 of the cold ones, and we will have 6 cold ones left for an answer of negative 6. In question 17, we have 8 cold cubes, and now we have to take out 5 hot ones. Again, we don't have any hot ones in there to take out, but if we rewrite this as negative 8 at negative 5, subtracting 5 is the same as adding negative 5, then now it makes more sense. We have 8 cold cubes already in the bowl, and we're adding in 5 more cold cubes, so we essentially have 13 cold cubes in the bowl for an answer of negative 13. Now, you should be prepared to finish the rest of these examples here on this page, and you have scrambled answers at the bottom. So if you don't get one of the answers at the bottom, then you have made a mistake, and you need to go back and check your work. Remember, no calculators as you do this. Before you pause the video and do those problems, however, let's work on lesson 1.6. 1.6 is really about multiplying and dividing real numbers rather than adding and subtracting. The key concept is that the product of two real numbers that have different signs is going to be negative. So a positive times a negative is negative. A negative times a positive is also negative. If you have a product or you're multiplying two real numbers with the same sign, like a positive times a positive, the answer will be positive. Even a negative times a negative is also positive. Does division work the same way? Yes, it does. The same rules apply to division. These questions also make sense in terms of hot and cold cubes, and if you're curious how that works, ask me in class and I'll explain it to you. Let's take a look at problem 1. What is each product? Part A says 12 times negative 8. Well, essentially what we want to do is just 12 times 8. So 8 times 12 is 96. But then a positive times a negative, they have different signs, so it would have to have an answer of negative 96. In part B, we're doing 24 times 0.5. 0.5 is the same as 1/2, so perhaps it's easier to think of this problem as 24 times 1/2, or what's half of 24? Well, the answer will be 12, and since both of these numbers are positive, it kind of goes without saying, the answer will be positive 12. In part C, we're multiplying two fractions. Now, you may have forgotten how that works, but basically you multiply straight across the top, and you multiply straight across the bottom. So the numerator of the answer would be 3, and the denominator would be 8. And then we just have to decide, is this going to be a positive answer or a negative? Since they have different signs, the answer will be negative. So we should get negative 3/8. Finally, in part D, we have negative 3 in parentheses squared. To square something means to multiply it by itself, so that's why it's rewritten again as negative 3 times a negative 3 to help us think it through. Now we can see that we're multiplying a negative times a negative. They have the same sign, so the answer is going to be positive, and 3 times 3 is 9. So the answer there is 9. So here are 4 practice problems for you to try. Got it? A, B, C, and D. Go ahead and pause the video for a moment and get the answers to those problems. Check back with me when you're done. Welcome back. How did you do with your answers to Got It number 1? Negative 90, 2.4, negative 21 over 50, and positive 16. If those are confusing for you, circle the one you want to ask about, and when you come to class, ask about it. Before we move on to practicing on all of this, let's try 3 more examples here to help us think through a few other division issues that we might have. What is 6 divided by 2? Well, you know the answer. It's 3. But how do we know that it's 3? Well, one easy way to explain it is we know that it's 3 because 3 times 2 equals 6. 3 times 2 equals 6. So if we think about that sort of logic on a question like 0 divided by 4, we can tell that the answer is going to be 0 because 0 times 4 will make 0. And that's the only answer that makes sense. Now, another way to think about these sometimes is, 6 divided by 2 is 3 because if you had 6 of any item and you divided it into 2 parts, there would be 3 in each part. The second question makes sense in the same way. If you had no money and you divided it equally among 4 people, then each person would get nothing. So the answer to the second example also makes sense. All of this is really leading up to the third problem. What is 5 divided by 0? And how do we know? This is the type of problem that students often get incorrect. Sometimes students think that anything with a 0 in it is going to have answer 0. But that really wouldn't make sense, because then that would mean whatever goes here has to multiply by 0 to make 5. So if I put a 0 in the box, 0 times 0 makes 0, not 5. So that doesn't work. In fact, if you stop and think about it, nothing is going to work, because no matter what I put in the box, when I multiply it by 0, it's not going to be 5, is it? Anything multiplied by 0 is going to make 0. So there is nothing I can put in this box, and that is why we call this an undefined number. That's why in math in general, or in algebra specifically, we say that you can't divide by 0. It just doesn't make any sense. Even if you think about it just in terms of an everyday life situation. You had let's say you had $5, and you wanted to divide that among 0 people. Well, the question doesn't even make sense. How can you take 5 and divide it up into no parts? Don't you kind of automatically have one part when you have the $5? So the question really just doesn't make any sense, and we call that undefined. Now you're going to have a chance to practice multiplying positive and negative integers. Just follow the rules for how those work. And again, do your best to do these without a calculator, because if you just punch it in your calculator, then you're not really practicing the rules. So you have 1/6a and b. For practice, b has two pages to it, and you still have some problems you need to finish back on 1/5. So go ahead and pause the video or stop the video and work on those, and just remember, do your best, forget the rest. Bye for now.